Hello everyone, myself Snehal Shinde, lecturer in Praveen Patil College of Diploma Engineering and Technology from Electrical Department. Subject is Elements of Electronics. Subject code is 22213, Unit 1, Semiconductor Diode. In previous video, we have studied and seen the overview of the course outcome and the teaching scheme, examination scheme, and the total numbers of chapters. From now, we will start chapter 1, that is the semiconductor diode. Learning outcome from chapter 1 is construction, symbol, working principle, specification, application, forward and reverse biasing, and VI characteristics of following semiconductors diode like PN junction diode, Zener diode, special diodes, LED, photodiode, laser diode, and power diode. So this diodes we will study in the chapter 1. So as the chapter name is semiconductor diode, so you have to know what is the meaning of the semiconductor. So normally there are three types of material: conductor, insulator, and semiconductor. Conductor, which allow the current to pass through it, which is having the low resistance. Insulator, which does not allow the current to pass through it and which is having a high resistance. So this is the conductor and insulator. So this semiconductor is which is having a property of conductor also and insulator also. Its property lies between the conductor and insulator. So a semiconductor material has an electrical conductivity value falling between that of a conductor materials like metallic copper, okay, and an insulator such as a glass. So semiconductor material property lies between conductor and insulator. So the conduction properties which are in between conductors and insulators. Then the semiconductors are classified into two types. First is the intrinsic semiconductor and other is the extrinsic semiconductor. The pure form of the semiconductor. Now what mean by this intrinsic semiconductor and the extrinsic semiconductor? The pure form of the semiconductor is known as the intrinsic semiconductor, and the semiconductor in which intentionally impurities is added for making it conductive is known as the extrinsic semiconductor. So to get the more detailed knowledge of the intrinsic semiconductor and extrinsic semiconductor, we will see this table, that is the differentiation between this. So before studying this, let me explain one more parameter, that is doping. You can see in this slide, doping of the impurity. So the method of increasing the conduction, the conductivity is increased by the means of the doping process. So in this process, the impurities are added to the pure form of the silicon or germanium. Semiconductor purest form is the silicon and germanium. So impurities are added. The impurities are the materials used to dope the intrinsic semiconductor materials. These materials can be of two types, that is donor impurity and acceptor impurity. First is the donor and second is the acceptor impurity. The material which is being used as an impurity in the doping process is called as a dopant. So, intrinsic semiconductor. Intrinsic means the pure. So, intrinsic semiconductors are the semiconductors in their simplest, purest possible form. Doping of the impurity in the intrinsic semiconductor is doping or addition of impurity does not take place in the intrinsic semiconductor. So here there is no addition of the impurity in the semiconductor. So it is the purest form of the semiconductor. Then in extrinsic semiconductor, a small amount of impurity is doped in a pure semiconductor for preparing extrinsic semiconductor. So in this extrinsic, a small form of impurity is added for preparing the extrinsic semiconductor. Then density of the electrons and holes. The number of free electrons in the conduction band is equal to the number of holes in the valence band. And in case of the extrinsic semiconductor, the number of electrons and holes are not equal because it will depend upon the adding of the impurity. Next parameter is the electrical conductivity. Electrical conductivity is low. Extrinsic semiconductor electrical conductivity is high. Then dependency of electrical conductivity. Electrical conductivity is a function of temperature alone, and electrical conductivity in extrinsic semiconductor, it depends on the temperature as well as on the amount of impurity doping in the pure semiconductor. So example of the crystalline pure form of the silicon and germanium are the example of the intrinsic semiconductor, and the example of extrinsic semiconductor is impurity like As, Sb, phosphorus, then indium, Al, aluminium are doped with the germanium and silicon atom. So this is the intrinsic and extrinsic semiconductor. So in intrinsic semiconductor, the presence of impurity, that is atoms of other material, is as low as 1 part 100 million parts of the semiconductor. The intrinsic semiconductors are equivalent to insulators or very poor conductors at room temperature. And in the extrinsic semiconductor, extrinsic means the impure, so we can obtain the extrinsic semiconductors by adding the impurities to them, and impurity is nothing but some other material. So the process of adding impurity is called as a doping. Due to the doping, the conductivity of the semiconductors increases. Thus, extrinsic semiconductor have a better conductivity than the intrinsic semiconductor. Therefore, they are used in manufacturing of all electronic components such as diodes, transistors. Thus, doping is necessary for increasing the conductivity of the pure intrinsic semiconductor. And further, this extrinsic semiconductor are two types, that is p-type semiconductor and n-type semiconductor. This we will see in the next slide. So as the term has defined that donor impurities and acceptor impurities, you will clear in this slide. So by the help of the difference or comparison, we will able to study the donor impurities and the acceptor impurities. So basic, the impurities that increases conductivity by donating charge is known as the donor impurities. Then those impurities that accepts the charge for increasing conductivity is known as a acceptor impurities. Then also referred as the donor impurities are referred as a pentavalent impurities, and the acceptor impurities are referred as a trivalent impurities. Now this penta means 5, tri means 3. So what is exact this? So the number of valence electrons in the outermost orbit of the molecule is 5. So it is known as a pentavalent impurity. And the trivalent impurity, that is 3 valence electron in the outermost orbit. So what is the pentavalent impurities? Are forms like N-type semiconductor, and the trivalent impurities form like P-type semiconductor. So group position in the periodic table is group number 5 of the donor impurities, and the group position in the periodic table in the acceptor impurities is the group number 3. Now the examples of donor impurities and the acceptor impurities is donor impurities. Example are phosphorus, bismuth, and acceptor impurities examples are aluminium and boron. So in this lecture we have studied semiconductor. Semiconductor means the property which lies between the conductor and insulator. It is known as a semiconductor. You know, conductor is having the high conductivity, that is, it allows the more electrons to flow. Insulator which does not allow the electrons to flow. And semiconductor property lies between these two. So semiconductor are of two types, intrinsic and extrinsic. Intrinsic means the pure form of the semiconductor. Extrinsic means if we add the impurities in it, so it is known as a extrinsic semiconductor. The main two types in extrinsic semiconductors are P-type semiconductor and N-type semiconductor. So this is the main, you have to study what is P-type semiconductor and N-type semiconductor in detail, because it forms the P-N junction diode that we have to study in this chapter. We have also seen what is the donor impurities and what is the acceptor impurities. Donor impurities means it is having the pentavalent impurities 5, and acceptor means it is having the 3. So pentavalent impurities are known as the N-type semiconductor is in the form, and trivalent impurities is in the form of the P-type semiconductor. So in next lecture we will study what is P-type semiconductor, what is N-type semiconductor, and the detail of the diodes. Thank you.